Hello everybody. I will talk a little bit about what data table actually is and why we started the project and what is its aims and goals. So the project started over two years ago, and at that point the main tool on the landscape for data manipulation was Pandas. It still remains the main tool, but back then other projects such as Dask and Arrow were in very initial stage and were basically not usable. So, and we really needed something to work with big data because we had the need for big data manipulation, and we needed to have a very high performance multi-threaded algorithm, full utilization of CPU, and so on. So we started this project as an alternative to Pandas. So we think of ourselves as a Pandas competitor. That part remained. Many things changed about the table over the years, but that part remained true until today. So we aim at being at doing the same thing as Pandas, only in a little bit better way. But it's also important to understand what the table is not. So I just said that we aim to be better than data table than Pandas, but we are not actually better than Pandas. We understand that, and we probably will never be better than Pandas in the sense that it's important. We believe that the core of our understanding is that we have to have a competition to build good products. Because if there is only a single product in any kind of landscape, then it will never be good, or maybe it will be good, but you will never know that it is good because you have nothing to compare against. So as long as you have several competitive products, you know that one of them is better in one place, other is in another place. So we are grateful to all those other competitors that we facing, and we are constantly strive to surpass them, and they constantly strive to surpass us. And this is why we believe that it is through this process of competition that we will actually achieve a great product, not by being just good by ourselves. So we talked about, I already mentioned that the main challenges for data table was that we wanted to support huge amounts of data. So currently we can process up to 100 gigabytes of data on a powerful machine, on a single node machine, and we aim to raise that limit probably at least 10 times in the coming year. So we wanted to have uniform support for missing values. So in Pandas there is some support on missing values, but not for all column types. In Arrow now they have support for missing values in all types. So missing features are extremely important in data science. So this is why it was on the top of our list, and we wanted it to be memory frugal, because we notice that sometimes it's not everything is about speed. Sometimes when you have really big data, it's important that the data does not overshoot your memory, because no matter how big a server is, even if it has a terabyte of RAM, for example, you still probably will end up having more data than your RAM. So it's important to be as frugal and as thrifty with your memory usage as possible. And this is one of our goals in designing the data table. And we'll talk a little bit about syntax, because for those of you who know R data table, can you raise hands who knows R data table? Oh, a few people. So those who familiar with R data table or at least seen it know that it has like a very interesting syntax, unlike everything else. So we borrowed that syntax, and it's a different approach to how you do things in Pandas, and you will see whether you like it or not. Some people like it, some people don't, but it's a distinctive approach, and we believe that it leads to more expressive power. So let's start with a high-level overview of the library. So we have a main class, which is a frame, and it is the same as equivalent of Pandas data frame. And notably, we don't have a series object. So in Pandas, you have both frames and series, which is columns in the frame. We don't have columns, at least externally. Everything is a frame. So it makes API a little bit simpler to work with. You don't need to swap between different object types. So then we also have these little helper functions, buy, join, sort, and update. They are used to perform basic operators, which are suggested by their names. And then there is this F symbol, which stands for frame proxy, and we'll talk about it a little bit more. It's a little bit mysterious looking right now. So then there is a namespace. In the main namespace, we also have a lot of other functions, such as sum, min, max, and notably most of the functions are in the main namespace, not on the main class, because the inspiration for API comes a little bit from R, and this is how things are done in R. So we also have math functions in the math namespace, and also we even have models, because we do a lot of machine learning algorithms. So some of the machine learning algorithms ended up bundled with the data table library. So let's start with a frame class. So first thing that is mentioned here is a class is 100% implemented in C. So this is because we really believe that the core of the library, the main class, must be as fast as possible. So there is not a single Python line of code in there. And it provides basic properties, same as you would expect from any other data frame: number of rows, number of columns, names, types. But inside a frame is just a simple collection of columns plus their names, and this collection is both an array and a dictionary. So you can think of it as something that is both a dictionary and array of columns. And I'm talking a little bit about the insights, because I think it is important when you use a library to understand a little bit how it is working inside, because then you can reason better about which operations, how much each operation costs. How much does it cost to select a column? How much does it cost to subset it? How much does it cost to make a sort, and so on? And if you have understanding of how the library does things internally, you can reason about that. Otherwise, you will end up producing inefficient code. So each column is a C++ object, and each column is a shared pointer. And shared pointer means that whenever we copy columns, we don't actually copy them, we just copy the pointer, and it means that it's a free operation, basically. So selecting columns, selecting subset of columns from a frame is a no-cost operation. So one important difference is that although we select columns by just sharing pointers, there is never a situation where changing one column affects everything else that was copied from that, because we use copy on write semantics. Copy on write semantics basically is whenever we try to modify the data in a column, it automatically creates a copy of itself and modifies the copy, and then everybody else remains with the old data. That way, you never end up in a situation where you select something, you saved it in a variable, and then from somewhere else it was modified, and then somehow the data became corrupted, and so on. And in order to battle that, usually you would see in the code people do deep copies all the time. Deep copy, deep copy, deep copy, deep copy. So in data table, we don't ever do deep copies. Like, we have that operation, but it's never useful. You can always just use a regular copy. So also each column has knowledge of its basic stats, such as min, max, sum, average, and so on. And these stats are memoized, which means that once you compute them, they are available for later use, and you don't need to recompute them. So many algorithms are actually can use the knowledge of the basic stats of the column and optimize some of the operations based on those stats. So if, for example, if you know that the range is small, the minimum between maximum, you can use one algorithm. If you know that there are no NAs in the column, you can use another algorithm. If you know that the string column contains only ASCII data, you can use a simpler algorithm and so on. So all of these simple stats are used to select a better performing algorithm at runtime. And one of the more important features that was introduced in the latest version is that the columns can also be virtual. And virtual means that they're computed on the fly. So we believe that it's an important part of our architecture because it allows us not to store as much data in memory. If you know that, because many of the things that we do with columns is do some kind of transformations, and then when you do transform, you end up storing the new data in memory, and then quickly you eat up all the available memory. And this is not something that we want to do. We would rather prefer to store the sequence of transformations that you apply to that column, and then materialize only the end result. So that way, the memory that was used to arrive at that final result was never consumed, which means that gets to that memory frugal part of our objective that we talked about. But in all respects, the virtual columns are completely transparent to the user. So you don't actually, you usually don't know whether a column is virtual or not. It just works perfectly. So here are some of the examples how it can be used. Let's say we are loading the data from a third-party library, let's say from NumPy. So instead of copying the data from a third source, from that other source, we create a virtual column that knows how to refer to that data. And this is, by the way, our approach to Arrow challenge. The challenge of the Arrow project was that there was too much copying being done between different projects. If you want to send data into other library, you need to copy it. You need to copy it from here, from there, instead of, and they say we need to have a common format so that everybody would use, and to achieve that common format is hard. Our answer to the same challenge is that we are going to just ingest the data without copying at all through the virtual columns. So we know how to read the data from different sources on the fly, and we don't need to copy that. So another example is if you want to select a subset of columns. That's a very common task. For example, you have a data set on 100 million rows, and you need to split it, train a test. So, and maybe a test data set is only 10 million rows. So you would create a set of indices, which rows you want to select, and then we would create just a virtual column that says retrieve me data from those indices. We will not actually select the data from those columns and copy it into a new frame. We will just say that we know how to retrieve that data, and this is done virtually on the fly. Similarly, when we are doing a join is an operation where we compute how the rows of one frame correspond to the rows of another frame, and then there is a row index, and no data is actually being copied into a final result. We just know how to compute the data in the end and present to the user. A grouping is a similar operation where we also compute the index of which observation corresponds to which group, and this allows us to ungroup on the fly and apply each operation to the ungrouped data. And of course, basic arithmetic operations such as functions, casts, and so on, they are natural candidates for virtual columns. And one other thing that we are planning to implement in the coming versions is to also support compressed data and encrypted data, and finally the sparse data as well. Everything actually can be implemented using the same paradigm. So now a little bit about the syntax. The name of the slide is DTIJ-BY. So if you have seen the R data table, you know what it is. If you did not, then this is the main frame method. So frame is our main class, and this is its main method. So it may seem weird like, why do we have a main method? Why don't we have like 100 different methods? And this is where the data table main idea is that we want to have a single method that does all the operations. And this is how we do it. So we say that, and this single method doesn't even have a name, it's just a square brackets. So we are saying that it has these parts, which I, which is selection of rows, and J, selection of columns. Then there are also additional verbs such as by, which tell us how to group operations, and join, what to join it with, and so on. So using that a single expression, we can actually implement pretty much all the operations that data operations that we need. And there is a nice parallel with SQL, because in SQL they also have a very limited number of main expressions, which is select something. So they say select J, which is in our case columns. So then from the data from a table where I is a condition of where to select. So this is a row selector, and then they also have the modifiers such as group, join, and order. So, and similarly they have in SQL also the main the delete and update verbs, and in Python delete is just a del operator and update is just an assignment. So using a single square bracket notation, we can achieve a lot of results, and you will see examples of that during the hands-on session. So what do we put in this IG bike? Right now it's just this abstract things, and we want to put there everything that we can think of. So basically, as long as you can assign some meaning to that anything and it's unambiguous, then we want to support it. So things like integer indices, strings, which would mean column names, slices, column slices, string slices, ranges, frames, NumPy arrays, Python types, data table types, lists, dictionaries, everything, even and finally the expressions. So expressions is the topic of the next slide, but basically we think that if you can put something there and you can say, I think this should mean this, and we don't support it, then we consider it a bug, right? We think that this syntax should be supporting any possible kind of expression. So let's talk about the expressions. Expressions is when you do calculations over the column. So first, the example of how you do things in pandas. In pandas, you would say you have a frame, you select a column, frame A, and then you select another column, frame B, and you add them. So this is how you write an expression in pandas. In data table, you use a square notation, so there is a frame and there is a square bracket applied to it. And remember that square bracket inside they have I, which is rows, and J, which is a column. So in this case, we don't care about anything, any filtering, so the I is just a column, which means select all rows, and then the J is what you do with columns. And in this case, it's f.a plus f.b. So f.a is a shortcut for column A of this frame. So f, you can think of it as this, or self. And it's a frame proxy, meaning that it automatically rebinds to whatever expression has been calculated in. So it's a little bit magical, but generally you can think of it as just a shortcut of how you refer to columns. Instead of having to repeat the name of the frame every single time, you just have a single letter F. And if you don't like the F, because some people don't like the F, you can just export the names of like what's below. You can say you can assign those variables to variables and then just use them as it is in a square bracket notation. So, but F is a powerful syntax, so it can be used not just as a dot notation. So dot notation is just the simplest kind. So if you have a more complicated column name, you can put it in square brackets. For example, if it's not an ID, or if you have a variable, you can put it in the square brackets. If you have an index, you can put it there. You can select a slice of columns. You can select a string slice of columns. You can select all columns. You can even select columns by type. And you can use those F expressions inside any kind of ij, by, and so on. And then once you select them, you can apply functions to those f. So for example, most of our functions, they automatically map through all the columns. So for example, the first expression here means it says mean of f float. So f float selects all the float type columns. Then mean of that means that the mean functions is applied to every one of those columns. So the result is that we will have a frame that contains the means of every single column. So the second expression says take the first 3 columns and the last 3 columns and add them together, so they will be added component-wise. The last expression says select all the integer columns and then assign the type, and assigning types means the typecast. So basically this just converts the type of all integer columns into float columns. We also have row-wise functions that takes a selection of columns, such as let's say all columns or all columns other than the last, and combines them into a single column. So row mean means that take all the columns and finds the average of all those columns. And in the last example, we take all the columns, we apply isNA function, which again maps across all the columns, and then we apply the any, row any, which means find me the row, those rows where any of the value in any column is an NA, and then delete those rows. So basically it deletes every row where there are any NAs. So in short, we believe that data table is a package that is an alternative to pandas. It doesn't have the full range of functionality the same as pandas, but it has its uses. In particularly, it's very useful when you face a lot of very big data payloads, such as tens of hundreds of gigabytes of data, and when you need a lot of interoperability with other frameworks. So in data table, we have a lot of data conversions from data table to pandas or to NumPy and back, and all of that is trying to do this a little copying. So, Anna, you next.
All right. Thank you, Pasha. So I know it's a lot of technical material for 9 o'clock in the morning on a Tuesday. So, but we're very grateful that you're here and that we have a chance to share more about this awesome library. So the next portion of this session, we're gonna do a bit more of the hands-on. Okay, so now we're going to come back to Aquarium. So I know there's a few of you who came in. So if you haven't done so, please go to aquarium.h2o.ai. We need to make sure that everyone has that environment. One of the requirements was to have data table installed and also to have a Jupyter lab. But we're actually going to provide that for you because I know that right now currently one of the limitations with data table is that it doesn't work on Windows unless you have a Docker container. So we're going to actually provide an environment for you. And that will be in aquarium.h2o.ai. You should see h2o.ai, and then you have Browse Labs. If you click on that, then you should be able to see an array of labs in here. We're going to pick lab 5. So it's titled, lab ID is number 5, and it's David Whiting's H2O3 and sparkling water. So we're not going to do anything with H2O3 and sparkling water, but we will be using the lab, a Jupyter Lab notebook in here. So again, you should be at aquarium.h2o.ai. You need to create an account. Once you create an account, there's going to be a password sent to your email right away, and then you can just log back in and go to Browse Labs. The dashboard. If you have something running, then the dashboard will look something like this, but we're not there yet. So let's go to Browse Labs and select Lab 5, Lab ID 5. Make sure you select that one because if you click on the other labs, which you are welcome to do so at some other time, it does take a while those labs have different notebooks, and they start like they take about 5 minutes to start. We're not there yet. We already have some pre-run environment for you. So if you click on Lab 5, you'll see something like this. Okay, so now we're going to select the Jupyter URL. So right at the bottom of the lab. So again, we're in lab number 5. So I went to Browse Labs, selected lab ID number 5, clicked on View Detail, and then right at the bottom, there's a section called Jupyter URL. We're going to click on that. So click on it, and then the following page should come up. Oh, the password? No, you should. Okay. Well, start the lab. I'm sorry. I guess mine already started. So click start, and then you should get a link right away. It shouldn't take long to. So if you're in the wrong lab, then you do click start, and it's just gonna take a long time because it hasn't preloaded. But if you click start, you should get the page here that I just had. Yeah. For the Jupyter lab. Okay. The password is H2O. So thank you for bearing with us. We just want to make sure everyone has the same environment and that you don't have to install anything on your machine. Okay, so we're there, H2O. Okay, so if you're there, then we're back to Jupyter Lab. Okay, now we're gonna go to GitHub to get the notebook. Okay, so the next one, we're gonna go to, this is the URL, https, I just have it here. Can you guys see that? It's https://github.com, H2O tutorials. Can you see that, the URL there? Okay, so if you go there, did everyone go to that URL? You should get, that's gonna take you to the GitHub repo for our tutorials. Is everyone there? Not yet? Okay, please let me know when I can move on. So I do have other instructions here if you want to follow, but I'll wait for everyone to mention the next steps. Okay, so we went to HTTPS and we went to the our GitHub repo for our tutorials. We have different branches. So this is a repo for H2O.ai. We have different products and therefore different tutorials. We are building our repo. So if you would like to explore some other time, we want to make sure that we have the latest and greatest of the product, specifically for driverless AI. But for this particular conference, we did a data table section. So if you go to branch, if you're not too familiar with, if you're familiar with GitHub, you can go to the branches and select AC PyData table dash tutorial. That would be where I have the folder that's called Python data table. So let me go to the repo. Bear with me, we're just trying to make sure we get the environment. We'll run the notebook quickly. Okay, so this is the GitHub repo. We're going to go to branch, and we're going to go to the one that says AC /PyData table tutorial. And that should only be one file. We go to Python data table, and there should only be one notebook there. Okay, so if you click on it, and then we're gonna right-click on raw and save the link. So pretty much what we're doing is we're just saving it to our local machine, so that way we can upload it into the notebook. So I'm gonna go back again. So we were in master when you. So we were in master, and then we went to the AC branch. And then we went to Python data table. And then you click on the notebook, and then you save it you right click on raw, and you save the link as. No, it should be the Python, the Jupyter extension. So if you save it to your local machine, then now we go back to the lab itself, and we're just gonna upload. So is everyone at the Jupyter section where we're gonna upload the? All we're doing is we're downloading the notebook from GitHub, and we're gonna upload it to Jupyter. So does everyone have the file in their local machine? Raise your hand if you don't have the file. So we have one. Okay. So do you guys mind helping them out? Okay. So we're gonna have some people walking around. So we went to GitHub for the tutorial site, and then we went ahead and so we went to the AC branch, and then selected the Python data table folder, and then selected the notebook inside of it. You click on it, and if you click right click on raw, you should be able to download it to your local machine. Okay, so are most of you guys there? Yeah? Who else is still not there? Raise your hand. Please make sure you raise your hand. We want to make sure that we all can follow. Okay, so now that we're here in Jupyter, we're gonna upload, and just select the notebook that you just downloaded. So it should be Introduction to Data Analysis with Python Data Table. Okay, so select the file, click open, and then it should look something like this. If you can see it. Okay, is everyone there? All right, and just click upload. So you have to click upload once and then upload again. Can you raise your hand if you're not at this page yet? Just one person? 2? 3? Okay. So only thing we have done is we created a query environment. We got a Jupyter Lab Jupyter Notebook running, but we just need to upload the file. Okay, so we do have a few people who are still not there yet. So I'm gonna try to, given that we have a short amount of time, just gonna click upload. Okay, so you should see the notebook. You can open it. As you can see, it's not complete because I found that when you're running Jupyter Notebooks, you can just click run, and it runs everything, and you kind of distract yourself, and you're like, okay, what did I just do? So this is gonna be a little bit of hands-on. We're going to I commented some stuff out. I also deleted some of the commands. So I will be asking you to enter some of the commands manually, and then so that way we can have a little bit. You can have some practice just entering some of the commands, so you can see how easy it is. So okay. So does everyone have the lab? I know, I'm sorry that this is taking a while, but I just want to make sure everyone has the lab so that everyone can experience how awesome data table is, and you'll be able to. We're going to be doing some comparisons between. We're gonna run data table, and then we're gonna run simultaneously the next command. We're gonna run pandas. So you can see the difference, and we want to make sure that you experience the difference. So everyone, and anyone else, still raise your hand if you're not here yet. Everyone's here? Okay, awesome. Okay, so as I mentioned before, the data set that we will be using is the Lending Club. Again, how many of you are not familiar with the Lending Club data set? Okay, so for those of you who are not familiar with the Lending Club data set, so the Lending Club is a non-traditional lending bank, you could say, that does peer lending. And so they provide personal loans, and they also provide small loans to businesses. So they actually, you can actually go and invest. And when you want it, if you want to invest, you can download the data set. You can see kind of like the information about the people, the type of people that apply for loans, and who gets, who gets awarded a loan, and who doesn't get awarded, and why they don't get awarded. So it's a really nice data set. From what I found, if you're not familiar with Kaggle, you can go to Kaggle. You can see the data set. But this particular data set that we're using, this one has 2.6 million rows and 145 columns. So we're talking a large data set. Some of the other data sets that I found for the Lending Club are much smaller. So the one that if you're going to Kaggle or if you're going to the Lending Club, you may get a different data set. So for this particular data set, which I last checked yesterday, is 2.6 million rows and 145 columns. So this will give us a nice chance to experience data table. Okay, so first thing we're going to do is we're going to import a Python data table. So I commented out for you, but the only thing you could do if you're using Jupyter Notebook, you could just do a pip install data table. And you can run that, and it'll run the latest version of data table, which in this case is 0.10, which was just released this morning. So we got a fresh version of data table. And the way to check that is if we go to the next cell, we're going to be importing some of the libraries. So as this is importing, I want to mention that for this particular data set, it's a very large data set. So we do get a chance to, it has information such as like ID, member ID, the loan amount. The maximum loan amount that people can get for a personal loan for Lending Club is $40,000. So the range is from like $500 to $40,000. You can request the amount, right? But how much actually do you get, do they lend out? So it has information about that. It has information about what the status of the loan is, whether the loan is current, whether they defaulted on the loan. It has for instance, the zip code, some parts of the zip code. Additionally, they have information about what's the reason. So some of them you'll find, some of them are trying to pay for, they have credit cards that they're trying to pay off. Other people are trying to maybe pay for a wedding, or maybe pay for college. So this is a very interesting, very diverse data set. I recommend that you check out Kaggle and you can play around with the data set. So for this, we're going to import the loan. So I provided two files. So the first file you're going to see is the actual loan data set. This is about close to 2 gigs. Of data, and then the browse notes is just a dictionary of the features, because some of them they're very cryptic. Some of the stuff I had to look up and be like, what does this mean? So if you have questions, you can we're actually going to bring it up so that way you can see, oh, okay, this is what the data set looks like, and if I don't know what the feature means, I can click on it. So you can select it there. So can you please run that? We're going to read it. So I guess the highlight here is really the DTF read. It's very simple. You could read, you could input, as you see, an URL, and you could also do it directly from your local machine. Let me show you the other one. I also have it. I installed Python data table in my machine, so you can also see the differences in terms of how fast it is when you're doing it locally. Okay, so let me see. Where are we? Okay, so now that we have the, did it run? Oh. So notice that we entered a time, so that way you can actually see how long it takes. From what my experience running this this notebook, it took about maybe like 30 seconds with data table for this particular notebook. But if you do it locally, it took about 5 seconds to do it, to upload 2.6 million rows. Or so, how many of you are done already uploading the data set? How long did it take for most of you? 30 seconds? Okay, so now try it with pandas. So run that and check to see how long that takes you. So that should take you about like 50 seconds or so. Okay. So I ran it too locally. And it took about 18.4 seconds. We'll see how long it takes for pandas. So we're still running, right? So this is one of the advantages, at least, that I found was it was awesome that it takes less time to upload, just to import the file. So I know you'll get a comment there. Yeah, 59 seconds. So we already see there are some benefits, right, to the data table, just on the using the DT data frame fread file. So that's how you import a data set. So we're there. Is everyone there? Everyone checked already? So we have to, the reason that I wanted to, so now we just imported the data set. And I just wanted to highlight, right, the time differences between the two. So as we're going through this lab, we're gonna be doing that. We're going to be running some simple commands, but I just want to show you the difference. We want to highlight the difference in terms of performance, because this is a library that it's we're highlighting performance. As Pasha said, we're not trying to replace pandas. We were going to show that you can actually work well together, right? There are things that you can do in pandas that you can convert to data table, and vice versa. Okay, so looking at the lone data frame, right? So we want to look at the well, what is the data? If you haven't seen the data frame, well, if you haven't seen the notebook or the data itself, how does it look like? So the way that you could do that is using I'm sorry, not what it looks like, but just the size of it. You can use the command here. I commented out, but if you take a print dt lone and you paste it and you run it, you should be able to see the shape of the data set. So again, the command should be comment in the comment section itself. So you could find out the shape of the data set. Run it. Right. You could do the same again for the figuring out the types. You can copy and just paste it and see. Okay, so those are again very simple commands that you could use to kind of understand a bit more of the data set. Okay, so I'm going to try to run this quickly because I know we also have. I want to make sure we have a time for questions. So if you want to look at you want to look at the data set, right? With data table, all you got to do is enter the name of the data frame. So when we imported the data set, we called it DT loan for data table loan. If you want to just see it, all you got to do is enter DT loan, the name of the data frame, and you get the first 10 rows followed by the last 5. So we did say, well, about 2, I'm sorry, that wasn't 2.6, it was 2.2 million. But this is what it looks like. And we even, Pasha and the team actually made it so that it's like celebratory. It's kind of has a holiday, it has a holiday theme. So I thought it was really awesome. Thank you, Pasha. That was really cool. Yeah, so you can see that it's very simple. You don't have to do use the head command. You could just do DT name the frame and it shows up. So what else can we do? You can do this is for the section where I was talking about the features, where if you wanted to understand what the features were, right? What does it mean? So you can actually look at the name of the feature of the column and look at the definition there. So again, it gives you the first 10 and the last 5. This is 145 features, so it will not. You can get a better idea, right? And it's really nicely laid out. Sorry, where am I? Right here. Okay, so that's the other part. So let's do some of the data wrangling. Pasha talked about already some of the commands and what the format should look like. So again, this is going to be like very high level. I know probably most of you are like expert data scientists. They could do very complicated analytical or just do different analysis, right, for the data wrangling. But we're not going to do that. I just want to show you what you can do if you're planning on doing data wrangling. So that way you can compare, right? You can see the performance. So we're going to delete the following columns. And how do we do that? So I have 2 notebooks running at the same time. Just one sec. So all you got to do is enter the following command to your notebook. And by the way, there's also a cheat sheet. I don't know if you guys can pass it around. We have it up here that has also commands for like how to delete. So we're gonna pretty much talk about some of the other commands that we're going to run. We're gonna run it on the notebook, but you can also reference the cheat sheet in case that you're like running behind, because some of the commands are not here. They will be posted on the official notebook once it gets published. But yeah, so all you gotta do is do delete. We have a delete function, and you could take the name of the frame, and because we're deleting those columns there are missing values. So the ID and member ID, they have the columns, but they're empty. Also the URL and the desk are missing values as well. So we're just gonna delete them. So you run shift, and it'll delete it for you. So just a heads up, the labs that we have in Aquarium, they only last 2 hours. So if you do want to check out the labs, they will expire after 2 hours. You will not be able to save any of your data. But it is really nice to use for exploration purposes. It does give you a warning, but you have to go to the Aquarium page. But you guys should be, I think you should be okay. So we're here. So I'm just going to use the one that I have on my local machine, but it should be the same commands. So we're going to look at the newly trimmed data frame, and again, we just have to enter DT loan. Simple as that. And you can see that, oh, I guess it did not delete that. You know how it is for when you're doing a demo. Everything works until you're actually doing the demo. So thank you for bearing with me. So as you can see, right, I just wanted to see, did it actually do it? Yes, it got rid of the ID, got rid of the member ID. Okay, so then the next part is we're going to, so this section is, you could do it in, I wanted to generate IDs, right? And you could do it with data table, but I just wanted to show you that you can do it in pandas. You can create a new data frame, and then you can bind it together, right? You can take a pandas newly created data frame, convert it to data table, and then bind it. So the way that you could do this is by doing the using pandas, right? You generate the new data frame, and to convert it, all you gotta do is take dt.frame, enter the name of the newly created of the pandas data frame. And we're gonna name it data table ID because that's the ID that was generated. And we're going to bind it. So again, this is just to highlight that you can go from pandas to data table to pandas. Very simple. Again, if you have some questions, you can look at the cheat sheet. It has different ways to convert from one to pandas to data frame to NumPy. So check it out. I recommend it. Okay, so again, now we just want to look at we want to specifically look at the new data table frame for ID. So we went ahead and created a pandas data frame where we generated IDs, or really an index, and then we converted that to a data table frame, and now we're just showing it. Any questions so far? No? I know it's very, like for most of you, probably it's like super basic. So now we're going to bind it. We're going to bind the newly created data frame ID with the data frame loan. So remember that in the original data table loan frame, we deleted the ID, but now we're going to add it back on. So we run it, and now we're going to view it. Okay, so simple as that. Okay, so this is the part where it gets good. So thank you for bearing with that one. Now we're going to do some exploratory analysis. We're going to look at the mean. So for the mean, we're going to calculate the mean using data table. Okay, so you should have the command should be on the comment. So it should look something like this. So it's a %time dt loan mean. Does everyone have that? Oops. Yes, are you there? We're going to calculate the mean at this point. And this is where we're going to start comparing pandas and data frame a bit more in terms of the performance. So this one took 2.3 seconds. Now we're going to run it with pandas. And just to note that the mean loan for this particular data set was 1,500. So again, we're talking about personal loans. Oh, wait. Just kidding. You're not supposed to run the pandas because it actually, my Jupyter lab kept crashing every time I try to calculate the mean. So don't run it. Run it at your own risk. I'm sorry. It is commented out for a reason. I think it says do not run, right, on yours? Yes, don't run it. So it was me. My bad. Okay, awesome. All right, so, but if you want to try it on your own at a different time, please do so, and you can see the differences. So now we just calculate the max, right? It's very simple. Take the name of the data frame that you created, and then dot max for the function. So the maximum, we already talked about at the beginning, it was $40,000. So, and then we do the minimum. And one thing that Pasha mentioned was that if you calculate the max, you also get the min. So you get 2 for 1. Is that correct, Pasha? Yes. Okay. So then if you're trying to calculate the min, then it's already there for you. It should be super fast. And again, we're just running this so you can see that it's the different functionalities for data table. So now you can calculate the mode. Turns out it was $10,000 for the mode, which is very consistent again. with the, if you look at the data table, at the data itself, and you can calculate the standard deviation. All right, so let me rush through sorting the frame. So we're gonna sort the frame using the data frame, Python data table. Okay, so sort it. I believe that yours should be commented out. So if you just uncomment it, you can run it. So it should look something where it has a percent time, sorted loans, and it took 84 microseconds. And you can again view it just so that you can confirm, right, that it was sorted. So it's sorted from the lowest amount, which is $500, and the highest, which is $4,000. So we're confirming that it actually did what it's supposed to do. What else do we have? Okay, so now let's do that with pandas. So again, 84.4 microseconds. Just take note. 6.3 seconds. Yes, with pandas. Okay. So now we're going to jump into the group by operations. So for this one, for group by, we're gonna do here is we're going to group the types of loans. So loans get graded differently, right, by risk. So we have type A, B, C, and D. So we're just gonna take the sum, right, of the types of loans that they have. And for this particular section of the code, what we did is we could run it once, but it's so fast that you're just gonna get 0 seconds. So you're not gonna really see the difference between the two. So we ran this command 100 times so that you can see it, how long it takes to run 100 times compared to pandas. So if you run it, takes 3.3 seconds. And if you want to view it, just to verify that it was actually done, you can view it too. And you can see the number of the loan amounts, right? For grade A, for B, C, D. Again, if you're not too familiar, if you want to learn more about what the grades are, what do they mean, you can go to the Lending Club site. They have all the definitions for that. Okay, so now let's do it with pandas and see how long it takes. So again, most of your in your cells, you should just uncomment them. I left them in there for you so that way it's just a little bit easier. Okay, so we got 3.3 seconds, and for pandas we have, at least for me, 8.74. How has it been for you guys? Because I know it might take a little longer on the Jupyter Lab. What are the times? What are we getting for group by, for data table? 3? Okay, with pandas? 9.6? 9.5? Okay, all right. So we see some, I know it's like seconds, but they start adding up at some point. Okay, for filtering rows, again, we did the same thing. We're filtering rows. We're running this 100 times, so that way we can see how long it takes. Okay. So you just run uncommented out. I know for you guys it's going to be uncommented. So for this particular section, we're filtering out the loans that are greater than the mean, and we found that the mean was 1,500 or so. So we're asking to filter about 2.6 million rows, right? Oh, it's not running. Just kidding. So I'm sorry if we're going kind of fast. I wish we could provide more of an explanation, but kind of short on time. So 9 seconds with Python. Again, this is just for me. You don't have to do it, but I wanted to see, like, oh, did it actually do it, right? Yeah, so it turns out here filtered out the loan, and it's cool too because that way you can see the ID, right? You can associate which loan amount, which of the loans, what was the amount of the loan, and who was the person, who was the ID of who was the person that got this loan, in case that you need to reference it for something else. Okay, so now we're gonna filter with pandas. took 2.5 seconds. What was the timing for you guys for filtering with pandas? Or for data table? 15 for pandas? Oh wow. Wait, 15 seconds? Oh, okay. Well, I guess this time, well, at least for me, yeah, I guess Panda did a little better. So again, we're not trying to compete. It's just more there's benefits to both. So for the model development, for this section, this is not necessarily data table, but it's more, we're just taking the sklearn and we're going to run a quick linear regression. We're just trying to see what the relationship is between the loan amount and installment and interest rate, right? So if you run it, we can kind of deduct by logic, right, that as the loan amount increases, that then the interest rate decreases, right, by this percent here. And as the installments increase, then your interest rate decreases, right? So that's what we, in a sense, what we can conclude from this. But again, you could do more of a model development. This is just like a very simple model development. If you want to learn more specifically about this linear regression, there is a great tutorial by SRK. He is one of our Kaggle grandmasters at H2O. He built this great tutorial. You can check it out. And he provides more information about this. So getting to the one of the parts that stood out to me is like, okay, now that I'm done, I want to save it. So if you want to save it, just save with Python data frame. And we're saving a CSV. For me, it took 2.9 seconds. I don't know how long it's going to take for you guys. How long did it take for you? Is anyone there yet? 1.3 seconds? Okay, now try with pandas. So one of the things that I did see for when I was running it in the Jupyter lab for aquarium is that it actually never gave me a time. But what you can do is that you can go back to the Jupyter lab, the initial page where we saw the different where we went to upload the lab, and you can see the two data sets, and you can see the size. And you can see that for data table, it actually uploaded the data set right away. And for pandas, it does it in chunks. So it takes much longer. So as you can see, I already have, it's still working on it. So I hope that you can see, right, that there are great advantages to using data table. Pandas works well as well. There's different things that you can do with both. We hope that you can see how easy it is to use. I know that for some of you who are not familiar with R, maybe the syntax maybe there might be a learning curve, but I definitely see that there's advantages for, and we do have great documentation, and we're also working on building more tutorials that are more extensive and more complex. So for those of you who do want to learn more about data table, you would be able to have an environment as well as kind of more tutorials to help you guide yourself with. So what's the next? This is just like version 1 of the tutorial. We're hoping for the next section we can have, next version of the tutorial, we can have create a section where we can create and update columns. We could do more joins, column selections, functions for multiple columns. And then another part too is that we do have a driverless AI, which Pasha mentioned. The whole reason that this library was created was because of driverless AI, right? And so driverless AI, it's really fast. And so you can actually do all your data wrangling with data table /pandas, and then create a J file and upload it to driverless AI, where you can develop a model, and you can actually have machine learning interpretation of your models. So we're going to be working on a tutorial for that where we can take you from creating a J file to the Python client to H2O driverless AI. So hopefully that'll be coming around January. We are hoping to post this tutorial on the GitHub page. I mean, there's a landing page that we have. This is what our tutorials page looks like. We have tutorials for driverless, tutorials for H2O, which is our open source product, and then we'll be adding data table as well here. So please, if you're interested, if you're curious, the notebook that I will be providing will have more information, and it will be like a walkthrough. So you'll have, it's not going to be like today where you're trying to run as much as you can quickly. You can run it at your own pace. So it looks like Jupyter is still working on downloading the data set. So, never mind. This is trying to run code when it's supposed to be marked down. All right. Okay, so as I mentioned, data science is a journey. So I know most of you are self-learners. Go and check out our tutorials. We also have great documentation for both data table and for the H2O products, if you're interested. H2O.ai provides the H2O aquarium, which you're welcome to use. We have labs for all our products, and we're going to be incorporating data table as well too. So again, if you just want to get started with data table, you can go to the data table repo. They have great documentation. As you saw, it's as simple as doing the pip install, and you'll get the latest and greatest of PyData table because we have hardworking makers who are constantly striving to make a great library. What else? So if you have any questions, if you're actually working on data table, you're using data table, you have questions, you can go to Stack Overflow, and you can go and use the tags data table Python, and you can search for questions that have already been posted. You can also go to if you actually want to contribute to the repo or you want to report an issue, you can go to the GitHub repo and create a new issue. If you would like to contribute to the data table project, you can contribute by improving documentation, report bugs, request features, have if you have API suggestions, if you want to test itself, you can do that. How you can contribute. First of all, if you want to contribute to the project, one of the recommendations that Pasha mentioned is that first check if there's an issue, first check that it's there. Or that if somebody is contributing too, you don't want to be working on the same project or the same thing if somebody else may be already working on it. So you want to make sure check that it already exists, right? If your contribution or something's already there, that you're not doing double the work. If it doesn't, create a new issue, and then Pasha, right? Pasha, you will get back to them to be able to provide guidance because it is a very large project, and it's not so much to tell you what you need to do, is more to say, hey, if you want to work on this is where you can go to search, and this is the resources available to you. So you get a better understanding of what the repo looks like and how to make it easier for you to contribute, because it could be a little scary, right? We don't know. We don't want to discourage you from not participating because it could be a little confusing. And then after you do that, just do your pull request. So, yeah, so thank you again. You guys have any questions and questions, and hopefully we have some answers for you. Any questions? We do have, again, we have two of the makers for this particular library here today, so please feel free to ask technical questions now at this point. Questions? Okay, the microphone's please wait for the microphone.
Thanks. Thanks very much for walking through this. It was very enlightening. I'm Ramsey from HRL Laboratories. I was just curious, could you explain a little more about how the virtual column thing works? I'm assuming that's why a lot of the processing was faster. Is that correct? And
yes, so a virtual column is basically a column that knows how to compute each and every of its elements. So usually it's a column that stores a pointer to some parent data and a function to compute the results on that data. So usually you will end up with a kind of DAG, the direct acyclic graph of computations. So you start with some initial data set, then you apply different transformations to multiple columns, and then they interact with each other, and you end up with columns that depend on multiple levels of multiple columns in the original data set. But still, it's just a complicated nested function of the original data. So, and basic observation is that to read and write into memory is a more expensive computation, is more time consuming than computing. So usually if you can read and write less and compute more, that's going to be beneficial for your performance, which is why we believe that it's good to have these computed on the fly columns. Even if you end up maybe performing some of the calculations multiple times, it still will cost you less time in the end than if you saved all those intermediate results into the memory and then read that from that memory again. So which is how standard approach, let's say in Pandas or NumPy does.
Thanks very much.
Hi there. Very cool library. Just curious, what was the thought process in creating a lot of the array extension types yourself instead of maybe using something like what PyArrow offers or PyArrow for performance and those native arrays?
So, as I mentioned, we started over 2 years ago, and at that point, Arrow was in a much younger stage than it is right now. It only barely started, and maybe if we started today the process, we could have used Arrow as a backend. And actually, we talked a little bit with Vas on our GitHub on how better to integrate the projects. We have an issue for that, and it was a little bit complicated because we initially chose a different memory layout than they've chosen in Arrow, because we came from R data table, but in the recent year we made a huge strides towards virtualizing that data storage. So now it's much easier to do that transition toward Arrow memory storage. So we are considering of having that backend as one of the possibilities built in, so that we could use them and they could use us more easily. Yeah. Hold on.
Sure. Hi. Any plans, to move into distributed computing, for example, to add support, Dask, Spark, something like that?
So we don't have immediate plans for distributed computing because we have Dask for that, and so Dask is a platform that takes pandas and distributes it, and it might as well just take data table and also distributed it using the same platform. So currently we do not have plans to distribute that, but it's possible that our calculation will change in the future, and we decide that this is a place to go. But in H2 we already have H2 library that is distributed data frames, so I kind of wanted to have something different. So. All right, thank you everybody.
So I know it's almost time to finish. So I just want to make sure personally to thank you for being patient with me. I know this was a long tutorial. Well, supposed to be a longer tutorial, but it's I know when you're running a tutorial on a notebook, you're trying to set up the environment and running the notebook itself, it could be rough. So thank you, and I would like to do a special thank you to the makers, Pasha and Alexi, as well as RK, Joe Granados and Rafael Cos. They also contributed to the presentation and the tutorial. So thank you all again. We will have a sprint session, right? The two makers will be there, and they will be answering any technical questions, correct? For the data table. So if you are kind of still thinking about questions and you want to maybe later on ask them like one-on-one, you can go ahead and ask them later. So thank you again for sitting here with us. And again, we'll be posting the tutorial, the notebook itself, on the website, on our tutorials website. So please feel free to check it out in a few weeks. And if you have any feedback, please feel free to provide any feedback as well. All right, thank you.